Hi guys, welcome back to Depth of ML. Today I'll be solving this question from GATE DA sample paper 2024 that was released by ISC. So there was no official answer key released by ISC. So we are solving these questions for you. So this is a NET type of question, which is numerical answer type question. Let's see the question. So the question is saying that consider a matrix X whose eigenvalues are 1, -1 and 3. Okay, so there are 3 eigenvalues that are given to us. And then they are asking about the trace of x cube minus 3x square. Okay, so they are asking what is the trace of x cube minus 3x square. Okay, so there are 2 approaches to solve this question. I will give both the approaches. So let's see how to solve this. So first of all, we should know what is a trace. Okay, what is a trace of matrix X? So trace of matrix X is nothing but all the eigenvalues. So we have 3 eigenvalues, so we'll sum those eigenvalues up. So where EI is the eigenvalue. Okay, so this is trace of a matrix. You will see trace being used in multiple GATE DA questions. This seems to be one of the favorite topics of GATE committee or people who set the GATE paper. So you should know what is a trace of a matrix. The next thing that we have to focus on, that they are asking not the trace of X but something like a polynomial of X, right? So we'll see how to do this. So let's see the first approach for this. So this is the first approach, and I will use something called as Cayley-Hamilton theorem. Cayley-Hamilton theorem to solve this question. Okay. So let me first tell you what is a Cayley-Hamilton theorem. So Cayley-Hamilton theorem says that every matrix satisfies its own characteristic polynomial. Okay, so what is Cayley-Hamilton theorem? It says that suppose P of X is the characteristic polynomial. If P of X is a characteristic polynomial of a matrix A, then P of A will also be 0, right? So we know that characteristic polynomial of a matrix satisfy this equation, right? So it also says that if we, instead of X is basically the eigenvalues. So instead of we put the matrix itself and we get into the same form, then we'll get the 0 matrix. Suppose that lambda square minus 2 lambda plus 1 is equals to 0 is a characteristic polynomial. For some matrix A. Characteristic polynomial of a matrix A. Then A square minus 2A plus I. So 1I. Okay, so this is I matrix will be equal to a 0 matrix. So this is 0 matrix. So I had solved another questions on Cayley-Hamilton theorem in previous videos, so you can check them out as well. Okay, so now that we have seen the Cayley-Hamilton theorem, let's see how we are going to use this. Okay, so first of all, what we'll do is we'll find the characteristic polynomial for this equation. First find characteristic polynomial for X. Okay, and how do we find the characteristic polynomial for X? So we are given that 1, -1 and 3 are eigenvalues, right? And we know that these eigenvalues will be root of the characteristic polynomial. So if I denote the eigenvalue with lambda, then lambda minus 1, lambda minus -1, which is lambda plus 1, and lambda minus 3 should be the characteristic polynomial. Okay, now I will open this up. So I will multiply these two first. So this is nothing but lambda square minus 1. This is A minus B into A plus B. So this is lambda square minus 1. Now I will multiply it with this. Okay, so this is lambda cube minus 3 lambda square minus lambda plus 3 is equals to 0. Fine. So now this is the equation that I'm getting. Fine. So I have lambda cube minus 3 lambda square minus lambda plus 3 is equals to 0. So this is my characteristic polynomial equation. Okay. Now what you have to observe is that the equation for which they are asking us the trace is actually part of this polynomial equation, right? Can you observe that the equation that they have given is x cube minus 3x square, right? Can you see that this is here already, right? So we'll use this equation now and Cayley-Hamilton theorem to form this. Like, we'll get an equal representation in some terms and then we'll see how to calculate the trace from there. Okay, so I know from CH theorem, so I'll call it CH theorem, Cayley-Hamilton theorem, that x cube minus 3x square minus x plus 3i is equals to 0, right? Because Cayley-Hamilton theorem says that every equation will also satisfy its characteristic polynomial. Okay, so it means that x cube minus 3x square minus x plus 3i, this is actually the identity matrix, is equals to 0. So let's continue from here. Okay, so now from here what I can do is x cube minus 3x square, I can take them to that right hand side, is equals to x minus 3i. Okay, and this is what they were asking. So we wanted to find the trace of this, and this equation is now equal to this, right? So we can say that trace of x cube minus 3x square is nothing but trace of x minus 3i, right? So this is easy for us. Trace of x we know because we know the 3 eigenvalues of this matrix x, and we know the eigenvalues of an identity matrix. They are all ones, right? Now, so how many ones should be there? So we'll see. So now I am calculating trace of x minus 3i. Okay, so trace can be distributed. So this is equal to trace of x minus trace of 3i, right? And trace is nothing but the sum of eigenvalues. So I can actually take this 3 out, and because it's inside, it's a sum. So what I'll do is, this is trace of x minus 3 of trace of I. Okay, now trace of x is nothing but the sum of the eigenvalues. So let's see what are the eigenvalues: 1, minus 1 and 3. Okay, so 1 plus minus 1 plus 3. And what is the trace of I? So I is a 3 cross 3 matrix. Okay, because there are 3 eigenvalues for x, and we have taken I, that is satisfying the characteristic polynomial here, right? So x will be 3 cross 3. Fine. So there will be 3 eigenvalues, all of them being 1. So if I add them up, it will be 1 plus 1 plus 1. Fine. So this cancels out. So this is 3 minus 3 into 3. Okay. This is 3 minus 9, which is equals to minus 6. Okay. So this is the answer. Fine. Okay. Now I want to show you another approach that can take lesser time than this approach, because here we had to calculate the characteristic polynomial and find this form, that whether this exists or not. There is a simpler way of doing this. Let's see that. Okay. Okay. So let me just copy this. Okay, now let's see the approach 2 for this. approach 2 for this. Okay, so this comes from something known as powers of a matrix. Okay, so what it says is that if A is a matrix with eigenvalue lambda, then A square will have eigenvalues lambda square, and A power k will have eigenvalues as lambda power k. Let's see why this is true. So we know that Ax is equals to lambda x, right? Where lambda is the corresponding eigenvalue to the eigenvector x, is the eigenvalue for eigenvector x, right? So if I multiply A on both sides, what will I get? A square x is equals to A lambda x, right? So lambda is a constant, so I can take it here and I will write Ax, right? What is Ax? It's again lambda x. So what we have is lambda into lambda x. So A square x is nothing but lambda square x, right? Similarly, if I have to say A cube x, okay, so this is, I know that this is A into lambda square x, right, which is A lambda square. I'll take outside because lambda square is a scalar, right? So it's a constant, so I can take it out. Then again Ax is lambda x, so I have lambda square into lambda x, which is lambda cube x. Fine. Similarly, A power k will be equal to lambda power kx. So what it says is that the eigenvalues of A power k will be just taken the same power, right? So if A power k is given, then the eigenvalues will be lambda power k, right? So now when we know this, can we calculate the trace of this matrix? Yes, we can. Fine. So let's see how to do this. So the matrix that they're given is x cube minus 3x square, right? So I'll find eigenvalues for x. So eigenvalues for x are nothing but 1, minus 1 and 3. So eigenvalues for x cube will be equal to 1 cube, minus 1 cube and 3 cube, which is nothing but 1, minus 1, and this is 27. Fine. Now we have to find the eigenvalues for x square, which is nothing but 1 square, minus 1 whole square, and then 3 square, which is 1, 1 and 9. Okay. Now this is simple. I have to calculate the trace of x cube minus 3x square, which will be equal to trace of x cube minus trace of 3x square, correct? Which will be trace of x cube, and because trace will be sum of eigenvalues, I can take the 3 out and I'll write trace of x square, right? So what is the trace of x cube? So the eigenvalues are 1, minus 1, 27. So we'll just sum them up. 1 minus 1 plus 27 minus 3 times trace of x square. Trace of x square is 1, 1 and 9, right? So we'll just add them. 1 plus 9. So this cancels out. This is 27 minus 3 times this is 11, right? So this is 27 minus 33, which is minus 6 again. Fine. So this is the same answer that we got from the previous method. So if you know this property, this method will be very faster compared to the one where we had to find the characteristic polynomial. Hope you like this problem. If you want us to solve any other problem, you can let us know in the comments. You can join our Telegram group as well, where we will be discussing more of such problems, and also a lot of discussion happens on this group. And you can check out our courses for GATE DA as well. See you in the next video.